Today, lesson 93, we're going to deal with equations that have exponents in them. We've actually already done this long time ago, but I think it's time for a reminder and see if we remember. This is the kind of stuff we're talking about here. Solve and check both equations, both solutions to each quadratic equation. So these are what we call quadratic equations because of that whole 2 with the exponent there that's squared. It changes everything. We've done much simpler versions of this. Today we're going to do kind of multi-step here. But the process remains the same. The first thing we're going to do, and some of you guys have described this as doing the order of operations backwards, and you're right. It does kind of work out that way. So what we want to do is get rid of that -3. So we're going to add 3 to both sides. And that'll give us 2x squared plus 32 equals 32, excuse me. Okay. Now we want to divide both sides by 2. Because that'll give us x squared by itself, and that'll give us x squared equals 16. Now the last thing to do to solve this equation is to take the square root of both sides, and that'll give us our answer, which is actually 2 answers, and the clue was kind of given to us in the directions because it says solve and check both solutions. 4 times 4 is 16, and -4 times -4 is 16. So the solutions to this equation are positive and -4. I could write this as 4 comma -4, or I can just save the time by writing plus or minus 4. And we're going to check these answers as well, so let's do that. 2 times 4 squared minus 3 should equal 29. That's 2 times 16 minus 3, which is 32 minus 3, which is 29. And we'll check the -4 as well. You can quickly see, of course, that's going to work because -4 times -4 is also 16. All right, so let's go do this example B here. Let's start out by subtracting 6 from both sides. That'll give us 5x squared equals 10. Then we'll divide both sides by 5, and we'll get x squared equals 2. And then we'll take the square root of both sides. We run into a bit of an issue when we start thinking about what is the square root of 2. Well, square root of 16 was no problem because 16 was a perfect square. 2 is not a perfect square. And if we want our answer to be exact, the only way we can do this is to say that x is plus or minus the square root of 2. We'll just leave it as the square root of 2. If we could simplify the radical, we'd simplify it, but we're definitely not going to punch it into the calculator and give a decimal answer because that decimal would be rounded. There's no way to represent the square root of 2 as a terminating or decimal that stops. And we can check this answer. We'll do 5 times the square root of 2 squared plus 6, the square root of 2 squared. The square root of 2 times the square root of 2 is just 2. And you can see that does indeed equal 16. And when we do the negative square root of 2 into this equation, negative square root of 2 times negative square root of 2 is also going to equal 2. And so that side, it would equal 16 as well. Let's do a few more of these. Let's subtract 8 from both sides on this one. That'll give us -7x squared equals -21. Then we'll divide both sides by -7. And that'll give us x squared equals 3. And then we'll take the square root of both sides. And that'll give us x equals plus or minus. And what's the square root of 3? The square root of 3. So plus or minus the square root of 3. Don't bother turning that into a decimal, and do remember that there's 2 solutions. Both positive square root of 3 and the negative square root of 3 work in this equation. So you got to put that plus minus sign, otherwise you're only giving me one of the 2 solutions to this equation. On D, let's add 24 to both sides. That'll give us 32 equals 4w squared. And then let's divide both sides by 4. That'll give us 8 equals w squared. And then let's take the square root of both sides. And the square root of 8, it's an irrational number, so we'll just say plus or minus the square root of 8. Now there is a little bit more to do here on this one, because 8 is divisible by a perfect square, 4. So we could rewrite the square root of 8 as the square root of 4 times the square root of 2, and then we could take the square root of 4. And this shouldn't be blowing anybody's minds because we've done this several times. So the square root of 4 is 2, and the square root of 2 is the square root of 2. In other words, I'm saying that the square root of 8 is equal to 2 times the square root of 2. So we need to simplify our radicals still. It's a little bit more advanced. Here's some proportions that we need to solve, and we can solve these proportions just like we've always solved proportions in the past, and that is that we use cross products. So if these two ratios are equal to each other, then their cross products should be equal to each other. So I'll show you what I mean. X times x is x squared, and 4 times 9 is 36. So the solution of this equation would be positive and negative 6. Just take the square root of both sides. So 4 over 6, that would be 2/3. And 6 over 9, that would also be 2/3. If you plug a negative in there, you'd have negative 2/3 equals negative 2/3. So that's the solution of that equation. You have two answers that solve it. Let's do it again here on F. X times x, cross products here, is x squared, and 3 times 4 is 12. So x squared equals 12, and then we'll take the square root of both sides. Square root of 12, 12 is divisible by a perfect square, 4. So let's go ahead and simplify that. And we'll say plus or minus 2 times the square root of 3. So in other words, 2 times the square root of 3 over 3 is equal to 4 over 2 times the square root of 3. Kind of ugly answer, but it's the answer nonetheless. One more example today. Yoli arranges 121 square tiles into one larger square. How many tiles are along each edge of the larger square? So we've got a big rectangle here that's 121 square tiles. We're trying to figure out how many tiles along the top and along the side would equal that. And it is a square, so x tiles along the top, x tiles along the side. So x squared equals 121. So we'd say plus or minus 11. However, negative 11 makes no sense in this case because you wouldn't have negative 11 tiles. So we'll just say that the answer is 11 tiles. So all we did here is base times height. X times x is x squared, and that should equal the area, which was given to us, 121. We solved that equation, which probably a lot of you guys could have solved it without setting up an equation, but we're setting up more complicated problems by being able to set up these easy equations. So 11 tiles wide, 11 tiles tall, and that'll give us 121 square tiles within that larger square. That's all I've got for today, and I'll see you tomorrow.